When you look up at the night sky, what do you see? You probably see a whole bunch of single, lonely stars. But what if I told you that's mostly a cosmic illusion? Let's pull back the curtain on the real choreography of our galaxy, the dance of suns.
So, let's start with a really simple question that kind of messes with everything we think we know. We see our sun as this solo act, right? The undisputed king of our solar system. But is that actually normal out there in the grand scheme of things?
Well, the answer is a big, resounding no. It turns out more than half of all stars in our galaxy aren't alone at all. They're in pairs or trios, sometimes even bigger groups. Our sun, being all by itself, well, that actually makes it a bit of a galactic outlier. The universe, it seems, really prefers companionship.
Okay, so how does this celestial ballet even work? How do two massive burning suns orbit each other? Well, it all comes down to the elegant and pretty unforgiving laws of gravity. Let's break down the physics that choreographs these incredible stellar partnerships.
The key to this whole performance is a concept called the barycenter. Now, this isn't a physical thing you can see. It's an invisible point in space. It's the shared center of mass that both stars are gravitationally tied to. You can think of it as the pivot point for their entire cosmic dance.
And where that pivot point is located all depends on the stars. If you have unequal partners, one really massive star and a much smaller companion, that balance point is actually inside the bigger star, so it looks like the little one is just orbiting the big one. But when two stars have a similar mass, the barycenter is out in the empty space between them, and you get this beautiful mirrored dance where they both swing around that empty point.
Of course, watching these dances from millions of light years away, that takes some pretty clever techniques. Astronomers have basically identified three main dance styles, and each one reveals different secrets about the stars performing.
First up, you've got the slow waltz. These are called visual binaries. A perfect example is Sirius, the brightest star in our night sky. These stars are actually far enough apart that with a powerful telescope, we can see them as two separate points of light. We can literally watch them trace these slow, majestic orbits over decades or even hundreds of years.
Then, things get a little more intimate with the hidden tango. These are spectroscopic binaries. They're so close together that they just look like a single star, no matter how hard we look, but their light gives them away. As one star zips towards us in its orbit, its light gets kind of squished into a blue shift. Then, as it moves away, the light gets stretched into a red shift. This constant rhythmic shift in their light is the dead giveaway to their frantic hidden dance. And finally, we get the most precise performance of all, eclipsing binaries. This is what happens when we get really lucky and their orbit is perfectly lined up with our point of view here on Earth. As one star passes in front of the other, it causes a predictable, regular dip in the system's brightness. A star like Algol, the demon star, does this so regularly that it lets astronomers measure the star's masses and sizes with incredible accuracy. It's like perfect celestial clockwork. But the dance isn't always so elegant and polite. When stars get really close, their gravitational hug can become transformative, intimate, and sometimes unbelievably violent. Sometimes, the dance turns deadly. The key here is something called the Roche lobe. Picture a teardrop-shaped bubble of gravitational influence around each star. That's its Roche lobe. Now, if a star gets older and starts to swell up, like when it becomes a red giant, it can actually grow so big that it overflows this boundary. And once its material crosses that line, there's no going back. It becomes a gravitational point of no return. And this process leads to one of the most powerful events in the entire universe. So here's how it goes down. Step 1. A star swells up and overflows its Roche slope. Step 2. All that material starts streaming onto its companion, which is usually a super-dense dead star called a white dwarf. Step 3. The white dwarf just greedily gobbles up all this stolen mass, getting heavier and heavier until it hits a critical tipping point. It's called the Chenza-Saker limit, about 1.4 times the mass of our sun. And Step 4, hitting that limit triggers a runaway thermonuclear explosion, a Type I supernova.
And the result isn't just a big bang, it's a cataclysm. For just a few short weeks, this one single event can outshine its entire home galaxy, a galaxy of billions of other stars. It's a final, spectacular, violent end to a very long and intimate dance.
But these dramatic endings aren't just cosmic fireworks. The legacy of this stellar dance is, well, it's profound. It forges some of the strangest objects in the universe, it seeds the galaxy with the heavy elements we need for planets, and it even gives us the tools to measure the universe itself. I mean, the final stages of these systems are just wild. You can end up with pairs of white dwarfs spiraling toward each other, or a neutron star locked in an orbit with a normal star. You can even get two black holes orbiting each other, and when they finally merge, they send out gravitational waves, actual ripples in the fabric of space-time.
And remember those Type 1a supernovae? Because they always explode at that exact same critical mass, they almost always have the same incredible brightness. This makes them what astronomers call standard candles. It's amazing. By comparing how bright they look from Earth to how bright we know they really are, we can calculate their distance with amazing precision. And by doing that, we can map the scale and the expansion of the entire universe.
So the big takeaway here is actually pretty simple, but it's also profound. Solitude, being alone like our sun, that's the exception, not the rule. From birth all the way to death, stellar interaction and partnership, this cosmic dance, is one of the fundamental engines of how the universe evolves.
And that leaves us with one last thought. We've seen how this incredible dance of suns can create cosmic yardsticks and shape the very systems where new worlds might one day form. So if a simple partnership between two stars can have such a huge impact, it just makes you wonder, what other secrets does the grand celestial ballet still hold for us?